Okay, good morning, everyone. We are just waiting 5 minutes for more people to join us. And then we will start our webinar. Okay. Welcome, everyone. We will start in just a couple of minutes to allow for other spectators to join us. So just stay with us. Okay. Okay. More people will join us, so I think that we can start the webinar. So welcome, everyone. You are on the Accessing H2SHIFT Facilities Open Call Preview webinar. I'm Ilaria Schiavi and from Environment Park, and I will be the moderator for the day. So let's just unpack the title of today's event. So we will be introducing H2SHIFT project. This is a project co-funded by the European Union through the Horizon Europe Research and Innovation Program. We will hear about the details of this project later on. But what you need to know is that H2SHIFT is an open innovation testbed, which has been organized to support innovation in the production of hydrogen. So we are actually a consortium which includes a number of test facilities which are making available their infrastructure and their modeling facilities to support innovators in increasing the option in the production of hydrogen. So today you will be among the first to understand how you can access these facilities through our open calls. I used a plural because indeed, and this is a spoiler alert, this is our first open call, which will be opening in the next few weeks, but there will be other opportunities as well to access our facilities. So let's have a look at the what was the program for today. So this is our agenda. We will have a welcome from MIRELA ATANASIU, who's the head of unit operations and communications in the Clean Hydrogen Partnership. And thank you, MIRELA, for being with us. Then with the coordinator of the project and the head of the single entry point, we will go through the details of what H2SHIFT project is. After that, we will deep dive into some of the facilities and testing infrastructure which are available for access through our open call. You will have opportunities to ask questions during this session, so make sure that you are able to access the Q&A session where you can write your question and I will be reading them up to the audience. After that, we will have a session on understanding how to apply for accessing to the H2 facilities. We will have a final opportunity for question and answer, and of course, the closure and more information and the contact details so you can stay in touch with us. So thank you very much. Let's start the session, and I'll leave the floor to MIRELA ATANASIU. Thank you.
Thank you very much, Ilaria, and thank you to the entire project. Thank you to the coordinator for having me. It's a very great pleasure for me to support this webinar today and to show, how can I say, commitment to work together. I know the project it's supported by Horizon Europe. It's not supported by the joint undertaking, by the partnership, but it came from a work that we had together with the European Commission, and where we decided that such initiatives of open innovation testbeds are necessary to complement our activities from the joint undertaking, and we will work together. And I'll come to that towards the end of my speech to propose a plan. So for those that do not know us, we are the public-private partnership of the European Commission, which is the public partner, and the private it's the two associations, Hydrogen Europe and Hydrogen Europe Research, who work together with the European Commission for more than 17 years to really bring the technologies into the market. This is the main scope of our activities, of course. We develop technologies. We push them up, if I can say that, the TRL, the technology readiness level. And of course, we move them into the market. We test them, we validate them, we demonstrate them, and then, of course, we learn and we go back into the lab. We have this feedback loop approach for more than 17 years, and in that one, we have, in some cases, in some technologies, went through 4 or 5 generations of products. I always give the example of our buses, because when we started in 2008, 2010, we were demonstrating buses with a capex of 1.5 million. And lately, with the projects Jive and Jive 2, with the 4th generation of buses, we brought the cost down to 500, 600,000 euro, for example. We have the same examples in the electrolysis, and I know that's more maybe relevant to the scope of your project, where we, back in 2011, we were working on a 150 kilowatt electrolyzer, PEM electrolyzer. And we with the support and with the development in the joint undertaking, and the support also from the different framework programs, starting in FP7, Horizon 2020, and now Horizon Europe, we push the limit up to 20-30 megawatts scale. These are the largest electrolyzers we are demonstrating, while decreasing the cost, of course, per megawatt. And this only in 15, 17 years. But, and I'm coming, and by the way, we supported more than 400 projects, 404 at this point, for more than 1.8 billion. We still have calls for 2026 and 2027. We are currently preparing the grants for another 30 projects from 2025. So we'll get probably closer to 450 or even more. And probably we will overcome the 2 billion euro investment over the last 17 up to 20 years. That will be, if I can summarize that. But, and that I'm coming, and now I'm coming to the but. In terms of Europe, and when we talk about even competitiveness, I dare to say, and when we talk about testing facilities, we work for a long time with our colleagues also in the Joint Research Center, and I think that I will also like to bring them into the picture for today's discussion, because we realized again back even 17 years ago when we started, that when we talk about testing, we don't have the same testing protocols. We don't have the same testing conditions, and we are not sure we are comparing apples with apples. When we talk about testing, when we talk about targets, profiles for testing, etc. So what we did already with the Joint Research Center, and I would like I said, for the scope of this discussion and of your project and working together to also remind everybody we have harmonized testing protocols that we published. They are open. Many reports published on our website, which I will refer everybody to. Joint Research Center has a testing facility also in Petten in the Netherlands. For mostly for fuel cells, and again, may not be necessarily the scope of your project because you look more into the beyond PEM and for other technologies and in particular for the production. But I think we need to be aware of what we have in Europe, what are the testing facilities in Europe, for which types of technologies. And if we talk about open innovation test beds, I think we need to keep that in mind. We would be very happy because this is exactly what we try to promote. We try to promote all these activities, in particular projects like yours, and we would be very happy to promote this call that you are having soon to all our beneficiaries. I also understand you are having the call for startups and SMEs. That's your target audience, and I think that's another link, if you want, I will make with our activities in the joint undertaking. We realized this year we did a bit of an exercise to look at how many SMEs we have supported, how the SMEs look into the sector, hydrogen sector in Europe. We support it for research and innovation, and we know that the industry, our industry, is SMEs based. It's a lot SMEs based, in particular when we talk technology development. And we realized we supported more than 800 SMEs with our support, as I mentioned, in the 400 projects. And some of them more successful than others. We know the geopolitical context and the economical context everywhere in the world, not only in Europe, and how technology development depends on public funding, of course, to cross the valley of death. And only 80 of them have leveraged additional private investment next to our funding of another 5 billion euro. So they benefited from our funding of several hundreds of million, and only 80 of them, which is very low, I have to say. It's about 20%. Only 8 of them leverage additional private investment. What the rest of the 80% of them will do, of course, they depend heavily on our public funding and, of course, of any other support that we can offer to them, hence opening testing bed facilities across Europe to support them because they don't have the funding, they don't have the budget, they don't have the money, I will even use that word, to invest in testing facilities or even to pay to get access to testing facilities. What we want to do next year, we will do a startup facility that we will announce in our work program in January 2026, next to the call 2026, in which we will also try to help them to get closer with their innovations to the investors, to leverage additional funding. And I think your project offering them also the testing facility, it's exactly the missing link from all the story that I just tried to make right now. So I think it's when I saw your invitation, I was so glad that we complete the picture and we sell even a better story in Europe for supporting our, like I said, many hundreds of startups and SMEs developing technologies in Europe and who need the public support and projects like yours to really help them. So, in a nutshell, and because I don't want to take too long with my introduction, great initiative. Happy to see progress. Happy to see the first call it's coming. Let's work together. Let's spread the call also through our channels. As you may know, I mean, okay, like I said, in 17 years of existence, we have a communication we have communication channels with tens of thousands of subscribers and all our beneficiaries, including the hundreds of SMEs and startups. So let's spread the word, and let's help the sector to proceed further. Really happy. You can count on us. You can count on the joint undertaking, and happy to work together. Thank you very much for having me again.
Thank you. Thank you, Mirela. We'll for sure take you up on the offer. And thanks again for your very, very interesting insight in the situation. And yes, we will be very, very happy to work together with you. Thanks a
Thank you.
lot. Thank you. Perfect. So we can now start proceeding, and I will leave the floor and the screen to our coordinator, Pietro Giovanni Santori from Snam, for introducing project H2SHIFT, and also ALISSA Bauer from CDI, Collège des ingénieurs, will explain a bit more about the single entry point. So, Pietro, please take it away.
Yes.
Thank you.
Thank you a lot, Ilaria. Good morning, everyone, and thanks for joining today to our webinar on the H2SHIFT project and for the opening of the open call. I will give you just a brief overview of the European project, what we want to do, what we are doing, and then I will leave to the open call leader and to the partners, owner of the test lines to give more information about the infrastructure. My name is Pietro Giovanni Santori. I work as a project coordinator here in H2SHIFT, but I work in Snam. For those who doesn't know, Snam is the main TSO, so transmission system operator in Italy and in Europe. We cover 38,000 kilometers of pipeline for transporting natural gas. We have a strong interest in the decarbonization, and to do this, we have the objective to accelerate the project oriented to the deployment of technologies for hydrogen production and not only. Regarding H2SHIFT, this is really, and was anticipated by Mirela, our scope. We want to accelerate innovative technologies that at the moment are not mature enough in order to meet the targets set from the European Commission. So in the past, in 2024, when the project started, the main target was to deploy up to 6 gigawatts of electrolyzers in Europe, up to 40 gigawatts in 2030. So those targets are quite late. We haven't yet achieved them because the electrolyzers are mature, in particular PEM and alkaline technologies, but not enough. So what we want to do is to accelerate technologies, innovative technologies in different fields. So not only electrolysis, where still we watch and we want to accelerate high temperature and anionics exchange membrane electrolyzers, but also looking to different technologies such direct solar hydrogen production through thermochemical water splitting or photoelectrochemical water splitting, different feedstock such as biogas, biomethane, bioalcohols in general, to produce again biohydrogen, which could be carbon neutral or in some cases also carbon negative. And finally, we want to see also to watch to offshore wind for hydrogen production. All of these will be accelerated within our test lines. We own up to 7 infrastructure for testing technologies in a TRL between more or less 3 to 4 up to 6, 7, 8. So we are speaking of pilot scale technologies that need a space with an industrial relevant space where to test, analyze performances, stability, durability of a technology, or to validate those technology in a de-risking way. So the infrastructure is ready, and the startup or the SME need just to enter, learn the space, and test the technology. You don't have to build your own infrastructure. That this is quite risky from a financial point of view, as you can imagine, need to build a facility to test the technology that might not work or might need more work to be updated. Here you can do it, and you can also use the expertise of test line owners that come from different fields, because as you can see, we have industries and corporates, we have research center, and we have universities. So there is a lot of expertise, a lot of know-how, a lot of possibility to explore solution to scale up technologies. And then we have two test lines oriented to the technology scale up through multi-physics modeling. Resolvent that will have speech today will give you more information about it. And some non-technical services, which means business development, go-to-market strategies, analysis from a techno-economical point of view of life cycles assessment, and also legal and regulatory framework assessment that often is an environment really difficult to understand, mainly for startups and SMEs. So we cover a little bit everything we need to know about hydrogen production and scale up of technologies. How we want to do it? We want to do it through the creation of the single entry point. This is the timeline that has been done during the first period of the project. The project has begun last year in 2024 and has seen the establishment of the legal entity, the single entry point that will behave as a main contact point, and more information will be given in the next few slides from ALISSA. And now we are showcasing some of the test line. What does it mean? So we are validating the single entry point and some infrastructure using internal partners that are startup and SMEs that are scaling up their technology. Now we are opening to open calls. We want to open the services outside the consortium in order to validate again the service and the single entry point, receiving feedbacks from users. We will open 2 waves of open calls. So the first one is limited to some of the infrastructure, while the second one will be open to all infrastructures. We will end the project in 2028. It will be the end of the funding period, but the beginning of the commercial operation and the services offered to external users. What we want to do is to expand this platform, to offer more services in the future, and to keep it alive for really, really a long time. To end my speech here, I want to show you just how we want to think. We thought about the process. We will have the single entry point that will be a little bit as a it will be the main contact point that on the toolbox and can address the user to the right infrastructure to receive the right services. So it's simplifying the life of a user. So before the user need to find the infrastructure, need to find who can test their technology. In here, you can access just to one single person that will study your application, will lead you to the right infrastructure or to the right service. All of this to lead to the creation in the development of innovative solution, the scale up to enter in a pre-commercial stage. Regarding the single entry point, I will leave now the word to ALISSA Bauer from CDI, that is the single entry point coordinator. ALISSA.
Thank you, Pietro. Yes, so as Pietro has already mentioned, the single entry point is there to simplify basically the access to all of the services and all of the activities that the H2SHIFT project wants to offer and wants to also build upon together with all of the external partners. So how this works in practice is for the first time now through the open calls, you can apply to collaborate and work with the H2SHIFT consortium and become an external partner. So you apply via the open calls, and this application arrives at the single entry point, which then first coordinates and filters all of the incoming applications. So if you respect all of the requirements, if it's a complete application, and then filters it already based on the availability also and the, let's say, the requirements from the single test lines. Then in the next step, the single entry point selects the matching application. So all of the applications that have, let's say, passed the first filter, and then assesses and analyzes the requests. Of course, also supported by the relevant partners from inside the H2SHIFT project. So we combine the expertise on the different test lines, of course, with a detailed evaluation structure. So there are specific requirements and specific criteria that will be analyzed, and based on them, the requests can then be matched to effectively the services and the test lines within the project itself. Through all of that, basically the SAP manages all of the first contacts with all types of external partners. So it is really the point of contact for all external activities that then matches the contact request or collaboration request of any type with the correct partners from inside the consortium. So instead of having to contact all of the different people involved in the different test lines or in other services of the project, you can directly ask all of your questions and send all of the applications to the single entry point, which then does the, let's say, matching work for you. Once in collaboration, so if you pass all of these steps and there is effectively a match inside of the consortium and inside of the project, each partner then manages the project-specific activities. So that is where the SAP hands over to the directly involved partners for each test line. This is just the first overview. Later, we will also go more in detail both into each test line and also into how the application process works, but without taking anything away from that, because Mara from Fondazioni Politecnico will speak about that in more detail. I will give the word back to Ilaria. Thank you.
Thank you. Thank you very much. And now we can start looking into the here we go. Sorry, I was just trying to share my screen. Let's go now into the description of the test lines. So we are introducing here the 4 test lines for which we are opening the application. So we will hear from each of the colleagues and then leave 5 minutes for question and answers. So as I mentioned at the beginning, please use the question and answer facilities of the webinar. Write your question and then I will read them and ask the people in charge to try and reply. If you don't see an answer or if you don't hear your question, don't worry, we will keep all the questions and then make sure that you obtain an answer later on. Okay, so let's start with Francesco Orsini from Politecnico di Torino, who will now introduce what we call test line number 5. Thank you, Francesco.
Yes, good morning. Good morning, everybody, and thank you, Ilaria, for the nice introduction. Can you see the presentation?
Yes, we can. Thank you, Francesco.
Good morning, everybody. I'm a postdoc researcher working at Politecnico di Torino, and it's a pleasure to present to all of you some more details on our test line 5 at Politecnico regarding thermochemical water splitting processes. So just to introduce a few numbers concerning the hydrogen research at Politecnico. So we have several laboratories around the city, I would say. For sure, some of the labs are located in the main engineering campus, the one that I'm highlighting now with the pointer. Another large part of the labs and of experimental facilities are located in Environment Park. So here in the northern part of the city as well. I will tell you something more in a while about it. And also, we do have some other benches in the Energy Center. That is actually another Politecnico building nearby the main campus. As you can see from these few numbers, several departments at Politecnico are involved in this kind of research. There are a large number of projects active in this area, and a consistent, I would say, number of researchers as well. What about the experimental laboratories of Politecnico located at Environment Park? That is, let's say, maybe the largest portion of labs. Here in the slide, you can see a picture of the lab. Here we have several test benches dedicated to hydrogen research, but not only for hydrogen. Of course, the focus of the H2SHIFT project is on hydrogen production, as the colleagues were mentioning before. So we have test benches dedicated to green hydrogen production, as I will mention later. Of course, there are also activities concerning hydrogen as an energy vector, and also the use of hydrogen as a reactant or co-reactant for conversion and valorization of carbon dioxide. Concerning the test benches dedicated to hydrogen production, some research is conducted on electrolysis as well, so low temperature, but also high temperature electrolysis, thermochemical cycles, that is the topic of interest for this specific presentation, and also, CO2 related activities not strictly related to this project. I would start from this part 1, so the part 1, let's say, of test line 5. That is, let's say, already available and fully operative already. You can see a couple of pictures on the right-hand side of the slide. This is the test bench, number 3, let's say, dedicated to chemical looping processes and specifically to chemical looping hydrogen production. Some of the specifications that maybe could be of interest for the audience. So basically, this test bench is fed by a electric power input. The temperature can go up to 1700 C, so around those high temperatures. So we can test basically, I would say, any kind of relevant cycle for producing hydrogen. The first part of the line is working at the moment at ambient pressure, and we can think of both vertical or horizontal setups. So we can use both vertical and horizontal furnaces for testing, let's say, I would say low TRL powders or pellet-like samples. Of course, the lab is fed by a large number of available gas lines. We can test water. We can use as a reactant steam. We have a steam generation unit here in this facility, but we can also use directly hydrogen, methane, CO2, CO, inner gases, or other relevant gas cylinders if we need some special mixtures. Which kind of services this, let's say, first piece of the story can offer? For sure, we can do experimental testing at the let's say microreactor level. We can test water splitting, the water splitting reaction Okay, also CO2 dissociation, but again, is not of strict interest here. We can assess both the durability and the stability of little prototypes or new materials, both on the, again, long duration stability, but also on the kinetic side. We have several instruments and equipment for gas analytics that is connected online to this facility. We do have infrared-based and thermal conductivity based gas analysis, but also mass spectrometry and gas chromatography. Everything here is basically automated. We have an automated software-hardware interaction, so interface, and we can program the customized experiment, I will say, and control it also remotely. This concerning, let's say, the first piece. I will pass then to this part 2. That is maybe the core of the H2SHIFT project-related activities. This facility is at the moment under commissioning. We are working together with our suppliers for the procurement phases. Unlike the previous expansion I was describing before, this new facility that is actually a solar simulator, so a high-flux solar simulator, will be placed in the main Politecnico engineering campus. You can see again a couple of pictures on the top. You can see a schematic of how this bench will look like. Basically, we will have at full load 4 xenon arc lamps based test bench with a full input power of 26 kilowatts electric. You can see here the lamps that will, let's say, convert the simulated solar radiation towards this focal plane, where basically the future users of this test bench will have the possibility to locate their solar device, the solar reactor, for example, prototype. The bottom figure instead represents a system basically similar to the one that will be installed at Politecnico. This is a picture from the suppliers of the test bench. So you can see these lamps and the focal plane illuminated and so on. Also in this case, we estimate similar temperature ranges for the operation of the test bench. Of course, this will depend on the specific case, on the specific materials being irradiated upon testing, on the specific reactor prototype, and finally on the specific internal conditions that the users will ask for. Also, the pressure will have the possibility to be calibrated. In terms of configuration, as you can see here, we are foreseeing a vertical irradiation direction. So the users will put their solar reactor here that will be irradiated vertically. Same story as before in terms of available gas lines. Of course, there will be the possibility to use steam, of course, but also all the other available gases that were already available in the previous test bench. And this is the full load input power that I was already mentioning before. What about the key services then? Of course, in this case, we are talking about a higher technology readiness level with respect to the previous test bench I've been mentioning. In this case, again, I just stress that the users will have the possibility, of course, to apply for this for the use of this test bench and to test their own reactor prototypes and devices for water splitting, so for producing thermochemical hydrogen via water splitting. So we are talking about a higher, again, between 6 and 7 in terms of technological maturity. That is the core, let's say, space of interest for the project. The test bench, of course, will allow to control the temperature in the reaction site, of course, and also here there will be the possibility to have extended gas analytics to follow the reaction products and behavior. Again, infrared-based, TCD-based, but also mass spectrometry and gas chromatography. Same story in terms of automation and software interfaces that is being developed together with the suppliers in order to allow a fully, again, automatized control of the experiments, and everything is foreseen again, of course, to be programmable and remotely controllable by remote. Again, this core facility of Politecnico and of test line 5 is under commissioning, and we foresee to have it ready basically soon in the next weeks. I would also mention a kind of part 3 that is somehow maybe beyond the test line 5. There is, let's say, a step forward, that is the solar concentrator, a solar dish concentrator, of which you can see a picture again in the slide. This third facility that can be used again for chemical looping hydrogen production is placed this time at Energy Center building nearby Politecnico. In terms of specifications, in terms of, let's say, nominal specifications of the solar concentrator, the temperatures that can be reached here are up to 1800 C, so pretty high temperatures again. Of course, this will depend on the specific weather conditions, experimental conditions, and so on and so forth. Of course, the main difference between from the previous solar simulator is that we would use real irradiation from the sun. So we do not have a controlled experimental environment, so it would be more challenging, of course. But in general, it will be possible. It is possible to use also here similar gases as the previous one. So again, steam, hydrogen, methane, CO2, and all the ones that you can see here listed. Again, services of this 3 of the facility. Of course, materials testing and testing of solar receiver reactors, again for water splitting, on-field demonstration, importantly, so using not simulated but real solar radiation. Same story as before in terms of typology of tests that can be run here and gas analytics that is being improved. It's again, as you can read, under repowering. And again, we are planning to repower this facility also in terms of automation, software interfaces, and programmable and remote control upon testing. So that's all from my side. Of course, I remain available if the audience have any kind of question, and I thank you for the attention.
Thank you. Thank you, Francesco. We actually have a question, but we will take it at the end of the session because I think that we can use it as a general reply for similar questions. So thank you, David, who asked this question, but please stay here and then we'll give you an answer later on. So there are no other questions, so I think that we can then pass the baton to SIMELYS HERNANDEZ, as well from Politecnico di Torino. She will be introducing test line number 6. So SIMELYS, hope you can share the screen and start the presentation. I don't see her. I don't know whether she can hear me. SIMELYS?
No.
Perfect. Okay, we can see that the sharing is started.
Can you hear me?
Yes, we can now. Okay, so the screen sharing has started. Let's give it a minute.
Okay.
Oh, okay, now the screen is shared. You can start.
Okay.
Thank you.
Politecnico di Torino, and I am in a different department from Francesco. I am in the department of Santa. And in particular, I grew at the we are in the engineering campus of Politecnico di Torino here, and I will show you the facilities and the activities that we can carry regarding green hydrogen production. So this process in scientific efficiency is what we are working to develop. We are offering to co-develop with the like for
SIMELYS? SIMELYS?
the kind of process.
SIMELYS, can you hear us okay? Okay. It looks like we have had some issues with SIMELYS connection, so perhaps we can switch to the next presentation while we recover SIMELYS. So, Lene, if you are ready, then we can just switch quickly to test line number 7. This will be introduced by LENE GOTTRUP BARFOD from resolvent, and maybe also Jonathan Daller from resolvent. Thank you very much. The floor is yours, Jonathan. And
you're welcome. And let's see if our sharing and sound works well. Ilaria, you can hear me well?
Yes, we can hear you very well. Let's try with the sharing.
Then we try with the sharing as well.
Okay, perfect. We can see it perfectly in presentation mode.
Very good. Then let's start. Yeah, thank you for the introduction. I named my test line 8, but maybe it is 7, but nevertheless, we are the digital test line, and I will give a brief on what that means, and also some examples of what we can do. Just shortly on our company, resolvent, and then also digging a little bit into what we see being challenging when you're doing technology development. Resolvent, we are a consultancy doing multiphysical simulation, and that is specifically focused around electrochemistry, flow, heat transfer, and structural mechanics, and the combination of those physics. We have worked more than 10 years in the green tech area, and this is also why we are very happy to be part of this consortium, because it very well fits with a lot of the experience that we have gained over the years. And we do see a lot of benefits, especially in the early stage development, where we, with the models that we are developing, can accelerate and also qualify many of the concepts that our customers are working with. So what are the challenges that we come across? Of course, many of you listening in here, you already know this, but you develop new things, so there is little or no prior knowledge. It's an issue that you do not have long-term testing, and it's also often difficult to get within a decent time frame. You need to understand the dynamics of a new system without having it built yet. And there's usually tight deadlines, both in terms of time and money. And your team is also often constrained to a few people, not having all types of experts at hand. These are some of the things that we try to target with the deliveries in this test line. And especially in the beginning of a development, you have huge opportunities to really benefit from having these digital investigations done. In this area, you do not yet have a production line, sub-supplier setups. So you have a large possibilities to influence, and you have great flexibility to do more designs, try it out, get learnings, and also here make sure you have a fairly robust solution. So when you are building your first prototype, you have a better chance of success. So this is really a good place to go digital before spending all your time and money on building prototypes. Yeah, a little bit more into how we foresee the work to be carried out. In this test line, we are making ourselves available for any startup or SME fitting the open calls. We can support the conceptual design validation and optimization, run sensitivity studies, and also do documentation and visualization of products or technology behavior. We do prefer to have interactions with physical tests as well, and I will dig a little bit more into why that is important. Right now, we are in several projects where that is the case, and they supplement each other really well. The workflow is that you meet up with us, potentially online, and you discuss the need and ambition for your technology testing, digging into also scale and what kind of physics to be involved in the modeling work as a start. Then we have to discuss on the available inputs, because having to work with new technology, it's usually limited, but some things can be found on material data, on geometry inputs. Maybe you have some test data available, and with all that in mind, we can set out in the best possible way. The frequent meetings we find very valuable, both to get to know each other, but the sparring that goes on in these meetings are usually very, very valuable to our customers, because the models we are developing, that makes the questions very easy to see and discuss. So if the model is showing something that you wonder about, then you would immediately dig into why is that? Is that the model setup, or is it something in the technology that we do not yet understand? Where should we look further for information? So these meetings is actually a huge part of where we see the value being unfolded. An example of the different scales that we can work on. Here is a lot of issues you could be interested in pursuing and understanding more of if you are doing alkaline electrolysis. And as you can see, and of course, many of you probably already realize as well, you have very different scales, and you have different issues to investigate in different in these different scales and parts of your product or your technology. So it's also about boiling it a little bit down to where is the biggest pain point, or which of these areas are most important to investigate. If we look at it from a more graphical point of view, you can go from the material investigations to units or more system models, and all of them are, of course, revealing insights and knowledge, but it can depend on the maturity of your technology, where you want to focus in a test line collaboration with us. Once we have these things set in stone, or at least set as well as needed for starting out, we will start the iteration and build complexity in the models as we go along. The visualizations are usually very valuable also in terms of communication and discussions internally in the team, and also towards your potential investors or board members. On the right-hand side is examples from another project where we have been modeling all the way from materials and units to actual prototypes and the first hydrogen production. So it is something that you can use in any scale of your technology development. Then we are often asked, how do you validate your models when the technology is new? And that is, of course, a challenge. Usually you have some knowledge available, either from literature studies or from a few tests. And these test results can definitely be used when you are validating your models, or we are. It's important to target some of the assumptions to make sure that we are, of course, looking at model results that can be useful and trustworthy. And here I brought a small example of another collaboration that we have with a green tech company. It's called Stargate Hydrogen, and they are a customer at our company and has been for some years, because they have these testing and team limitations. So they can do some testing and they have a large team, but they do not have specialists on all positions. So they use us as their modeling team. That provides them with speed and, of course, also knowledge to study and understand the dynamics of their system. And one of the things we have done together is to try to validate these models, and they are developing as we move. So things are changing often. But here you see the top row is the images of a test where they are using a die to show the flow pattern. And below you have the, you could say, the similar images from the simulations. And I brought this because sometimes we need to be a bit creative in how we do testing that can be used to validate our models. It's not necessarily a full test of X operating condition points, but it can be something a little less, it's not what you want to do in real life, but it shows you the pattern, and therefore we can actually use it for validating the model. So it's also a way of finding validation data without having the exact system. And we have a lot of experience in guiding on this as well. So if you are a startup without too many data, don't hesitate to reach out anyway. We will guide you on this aspect as well. Another example is from within the consortium, where we are showcasing here in the next slides how a potential deliverable could look in this digital test line. So aside from getting your results, it's also important for us that the user can interact with the models, also without being a modeling expert. And we are used to building these interfaces and to define what kind of inputs and potential outputs our customers require or benefit from. And this is an example of how you can interact online with the models that we have developed. And then you can select what inputs you want to be able to change. Then you have the 3D version of your, for example, cell in this case. And then you can set the simulation to run. And one of the benefits for this is that once the model is there, you can do a lot of scenario testing without having to reach out to us. And as an agile way of gaining more insights to your product or to your system. Now we will see in the short video here how the results could look like. We get questions on documentation as well. So in this way, you can also document what types of simulations you have been running, and then use that as a supplement to your physical testing or literature investigations. In this example, we are following the velocity distribution in different flow channels, and you can see that in the edges you have a much larger, in this case, mass flow we're looking at now. You get the visuals with the nice color graphs that can easily be understood by not only technical people, but also potential business developers and marketing people, not having to know the details of everything, but to get a nice communication platform where you can also show what happens if you change the geometry or the operating conditions. Yeah, you can dive further in. So that is one of them. I'll just skip to the next slide here. So arriving at what we can do together is that for us, when we look at the technology scale up, having modeling as a parallel track is, at least in our mind, not optional, but needed in order to speed up your development, but also to qualify your development and to get you the insights that you need in order to improve your product or your process in the right way. It allows you to make more informed plans and thereby development decisions. And you can use the tools for further iterations and optimizations, which is something that especially benefits when you are putting your product out there with the client. Then you will also get a lot of new questions that you can then investigate via the models built. And another aspect that has been more and more asked for is also to use the data from simulations when you are applying for certificates. More of these institutes or regulatory parties, they are also starting to accept digital tests as a supplement to the physical testing. And that allows also for the modeling work to take an active part in this area of technology development. Yeah, and then it's always important to make sure you are discussing the right things with the right people, and the visualizations have proven many times that it's a big help to be able to point and show and interact with visualization of your process. It's a lot easier to view inside your product or your process with a model than it is to look inside a reactor made of stainless steel. So here you really have the opportunity to also both show and have a look at what actually goes on behind the metal shells. Yeah, that was what I have chosen to bring today. And please ask questions to me or Jonathan if you have any. One of us will for sure stay throughout the meeting, and we look forward to collaborate.
Thank you. Thank you very much, Lene. There are no questions so far from the audience, apart from an expression of interest for this facility, which is really good. So I think that we can now get back to SIMELYS, who should have solved the little technical issue that she had. So SIMELYS, can you hear us now?
Yes, yes, thank you. Sorry for the problems. I had technical issues in my computer, in my connection.
No problems.
So I will just try to just briefly start again my presentation, because probably there were not good voice. Yeah, so good morning again. I am SIMELYS HERNANDEZ, an associate professor at Politecnico di Torino, and in particular I work in the Department of Applied Science and Technology. But are you seeing the screen? Sorry?
Not just yet.
No, sorry.
Share. Thank
you.
you.
Let me see. Okay, now
it's coming. Now we can see the presentation in the correct visualization. Thank you.
Okay, great. So, okay. Our testing facilities related to the photoelectrocatalytic hydrogen production, or more broadly water splitting, is in the engineering campus here in Politecnico di Torino in Turin, as I mentioned, in the DSAT department. And what this facility is about is related to the process that is so-called artificial photosynthesis in the scientific community, and is well represented in this picture with something that can look like an artificial leaf. And the idea here is to split the water molecule to be able to produce hydrogen and obviously also oxygen from the oxygen molecules in the water. But as we will see, this hydrogen or the protons coming from the water can also be exploited for other reactions. But first of all, I'd like to just briefly review what are the types of setups that we can test in our facilities and that are of interest for the development and research and development for hydrogen production. In particular, we can have these three kinds of photocatalytic or photoelectrocatalytic systems. Here in the top, you see the typical configuration where you put the catalyst in the powder form in a water media. And based on the bang up usually of the semiconductor materials, of the photocatalyst materials, we are able to split the water molecule thanks to the energy coming from the sunlight. And the holes that remains on the valence band of the semiconductor if they have enough oxidative power, they can split the water molecule, producing oxygen. And the protons coming from the water splitting can then be reconverted with the electrons in hydrogen molecules. So here in this kind of system, we can have the full splitting of the water molecule into hydrogen and oxygen. And this is what usually from a test you can observe, the evolution of the oxygen and water and hydrogen in a stoichiometric ratio. Then there are also another setups that are called photoelectrocatalytic systems, in which we need photoelectrodes for that given a certain irradiation with enough energy that is able to be absorbed by the catalyst material put in the electrodes, we can also perform this water splitting process, but separated in two different chambers. In this kind of setups, we are able to produce the oxygen molecules and the hydrogen molecules in two separated chambers, and we are able already to have a more pure hydrogen stream respect to the photocatalytic systems. And finally, in the third kind of device, the PVEC system, we can couple photovoltaic panels that can convert solar energy to electrical energy together with electrochemical or electrolyzers in order to perform this hydrogen production with sunlight, but in an integrated system. So in our facilities, actually, we are able to exploit and to test these different kinds of reactors. And the overall goal of our research and also of the collaborations that we pursue are to tackle the actual challenges that are nowadays for the practical sun-driven hydrogen production or exploitation of this green hydrogen for other reactions. So what are those such challenges? We know that it's needed to achieve a solar to hydrogen conversion efficiency higher than 10% to make this sun-driven system feasible for the practical application. Obviously, the hydrogen production costs should be competitive with respect to the current price of its production. And from the technological point of view, the major challenges are related to the scalability of the process. So the scalability of the synthesis of the electrodes, the scalability and stability of the materials that are tested, and so it's needed to have facilities for long-term testing of the electrocatalyst, photoelectrocatalyst or catalyst materials. Is needed to be able to evaluate the efficiency of conversion of water into the products, hydrogen, oxygen, in a continuous mode. And is needed to develop these modular and scalable cell designs that have bigger size respect to the lab test bench, and so are needed facilities to test these scaled devices. So in our facilities, we actually are able to span between different kind of competence and facilities that allow us to study from the atomic scale, so atomic interactions via some computational modeling activities. We have capacity and facilities to make preparation and scaling up or assessing the scalable production of catalyst and photocatalyst materials, capabilities for scaling up and manufacturing in a reproducible way electrodes, testing facilities for different scales and different configuration of photoelectrochemical and electrochemical reactors, and competencies on techno-economical analysis and sustainability studies. Here you can see the core of our test line 6, where we have different, we can exploit this for different applications, obviously for green hydrogen production through the methods that I already explained, but we are also able to use for another applications. And the major features of this test bench are the fact that we can control in an automated way with a computerized control system. We can control flow rates, pressure, temperature in the system. We are able to operate up to 30 bars of pressure. We are able to work up to 100 to 150 Celsius degrees, and with a broad range of pH conditions. We can operate not only with water or water vapor, but we can also insert different inner gases to evaluate site reactions, for example, or other conversion process, like, for example, in the case of carbon dioxide. And we have some simulators that can allow us to range between 1 SAN, that is a typical standard for testing photoelectrocatalytic and photocatalytic system, up to about 10 SANs, depending on the size of the illuminated area that is needed. We have the capability also to do gas products analysis with different techniques, gas chromatograph or HPLC. In our facilities, we also have the competencies to develop standardized wet synthesis methods. And here you see some examples of the kind of processes that we have handled in the past and have also standardized to be scaled up. Regarding the electrodes production, here you can see the one of our setups for doing this. So it's a spray coating system, and in the framework of H2SHIFT, also we bought a new equipment that is going to arrive here that allow us to develop electrodes up to 40 by 40 centimeters. Just to show you a couple of projects in which we have been working and we have experienced the scaling up of these kind of technologies. Here you see the scaled up prototype of 1 square meter of the artificial project. That was a prototype of artificial leaf, so a photoelectrochemical system driven directly by sunlight, so a self-standing system that also was coupled with some photovoltaic panels for hydrogen production. And the last example is the just finished Sankoken project funded by the Horizon 2020, in which last year we completed a test bench validation at TRL 5 with a photoelectrochemical system for carbon dioxide conversion to syngas, and then to use the syngas in the production of other aldehyde molecules. That was showcased in Eurecat in Tarragona, in 2024. And with this, I leave my contacts. So we are open surely for discussion, for collaboration, and thank you. If you have any question, I'm happy to answer.
Thank you very much, SIMELYS. So at the moment, we don't have any question. I remind the audience that you can see all the technical details of the test lines on our website. We'll give you the details later on. And also, I urge you to use the facilities for question and answer so we can interact with you during this webinar. But don't worry, of course, we are always available for further information. And now, last test line that is open for this call, which is test line number 7. So apologies for my error before. So we have now EDVALD EDVALDSSON from Youwind, who will introduce test line number 7. Edvald, if you would like to share your screen.
Yes, thanks, Ilaria. Happy to get started. So let me just share my screen here. Can you see this here?
You are, yes. Can you switch to presentation mode? Yeah. Let's see if the system responds. Not yet. We are still seeing the presentation in edit mode.
Right now, it's okay.
And now we are seeing it in presentation mode. Thank you.
Very good.
Take it away. Thank you.
All right, very good. Thank you very much. Hi, everyone. Happy to present here test line number 7 and the work we're doing here at Youwind. So test line number 7 in the H2SHIFT project is essentially hydrogen in an offshore environment, as it's called. So throughout this presentation, I'm going to explain a little bit what is it we are doing in Youwind, how we work in general, and how our collaboration is with this consortium in H2SHIFT. Youwind is an IT company basically focusing on offshore wind farm and onshore wind farm development. We were founded in 2018, and our digital solutions are focusing on streamlining the workflows on optimizing the development of offshore wind farms. And offshore wind farms, we are related to wind turbines at sea, just to highlight that. We're focused on, we are an employee-owned company. So we have in our hands wind experts with all of them more than 10 years experience. And we are very focused on offering integrated, seamless, and bankable results for offshore wind farm design. The Youwind platform itself is an IT platform, as mentioned before. We are behind major developers of offshore wind farms and behind over 20 awarded wind farm projects. So the Youwind system and company, we are offering a solid foundation of basically hand-on experience and technical precision, and quite known in the industry for common players like Wind Data of Vortex. So just to show you very briefly what Youwind is about, and I wanted to show everyone this just to understand where this test line comes from and how everything is integrated into one. So essentially, Youwind is an offshore wind farm optimization platform, as I mentioned before, where the focus is looking at primarily on GIS functions, so geographical information systems, where you're mapping out your area to identify offshore wind farm opportunities, where essentially you need to look at what are the mapping restrictions, exclusion zones. In the North Sea, you're looking at where are the mine zones, where are wrecks, etc. So this is, let's say, the first part of the platform where you're looking at types of mapping and you're trying to scope where is it actually you can start developing offshore wind farms. And then you jump into, let's say, the next step, which is looking at the wind resource. So the main power that you can get out of these projects, to say it like that, is to look at how high and how constant is the wind speed at each location. So from here, you can also add different and analyze different wind data where you can start optimizing your projects. And then becomes the more engineering functions of actually validating and advancing with wake models. So essentially to see how much power can you get out of these wind farms, how many turbines should you place, and are there any shadowing of wind coming from neighboring wind farms? So that's also something that the Youwind does, is optimization on how you actually place the turbine positions. What types of foundations do you add? Is it a floating foundation? Is it a fixed bottom foundation? And then you see exactly how much power output you can get out of by adding also the electrical system design. So you calculate how many cables do you need to connect the turbines, how much is the actual power output, and how actually what are the temperature losses, what are the electrical losses, etc. And everything is sort of fed into a yield assessment where you're sort of saying, I have this wind farm, how much can it produce, and how much will it cost to produce? What we're focusing on in this particular project is implementing hydrogen production into the mix. So when we're talking about pre-screening, we also want to do pre-screening on seeing where are potential big industry around the neighboring, around the offshore wind farm, where it can actually be interesting to implement and design an electrolyzer, bigger system where they can offtake some of the hydrogen that might be produced with this green electricity that comes out of the offshore wind farm design. So this is sort of, let's say, implementing the pre-screening, where are opportunities for hydrogen production and where are potential off-takers. And then in the layout design, you're sort of trying to pick out where can hydrogen actually fit into the mix. And then the third part is basically optimization. So it's actually looking at how do you optimize the production, looking at supporting different objectives, so the revenue, profit, and AAP. So essentially, we are implementing a full optimization on if there is any grid curtailment on a given location, how do you actually implement that in the business case on saying, well, if you don't want to have this curtailment, maybe you can divert this electricity production in another place. Can be batteries or can be hydrogen production. And that's something that we are focusing on this project. So the overview of the test line 7 is essentially that we are developing this advanced hydrogen production, storage, and transportation simulation module. And we will integrate this fully into the Youwind platform to be used as a part of the analysis that the users make for optimizations. So in terms of key capabilities, so we want to use the time series of electricity as the core input. So that basically means that if you have a power purchase agreement with any off-taker, that's the input. Or you're looking at electricity prices as a market price, that's also a core input, because that basically defines on how you optimize the revenue in the offshore wind farm design and how you figure out how you want to have this sort of co-located production on looking at hydrogen storage and even transport strategies when we're looking at and transport. And of course, what the goal is essentially that we want to help developers, so offshore wind developers and authorities, to determine what is the highest value configuration of this storage. So the concept is essentially this. So we require some inputs from the hydrogen facility. So the connections, the time series, we need to evaluate what is the cost, capital expenditure and operational expenditure of the systems. And then we actually need to see what are the results, which is essentially the optimal sizing. And this basically is then fed back to the layout generator of the application, because it could be that the optimization or the capacity could be optimized further, looking at even an overplanting of a scenario, because that essentially has a very big impact on the business case. But if there are curtailments in the system, that's not such of a big interest, because obviously you don't want to integrate a 25 million offshore wind turbine when you might be curtailed at any moment. But if you would have an opportunity to implement another strategy, another offtake strategy, such as hydrogen or battery energy storage, then this business case and this interest might become of even better use. And obviously here, especially for the European market, we are then making sure that the green electricity, the green electrons in the systems are better utilized. So that's also what we want to aim for at this. So the co-located plants is essentially where you have your wind farm, you have your time series, and then you have your pricing. And then we want to integrate that into, let's say, this optimization on how you make sure that the business case of of hydrogen is valid for here. Now, what are we looking for in this test line 7? So we are very keen on working with an innovative partner to actually help mature these modules. So this can be either a young or an agile company based in the sector, a new startup, or can also be just a major player that just wants to make sure that the solution that we want to develop is validated through this H2SHIFT project. So the ways that we envision ourselves to collaborate, so essentially looking at the code development of this simulation module. It can also be technical validation of this modeling and assumptions. It can also be looking at what exactly is it the expertise support, and hydrogen production, compression, storage, and transport is also something we are quite keen on. And then it could also be further integration partnerships. So this could be potential partnerships and actually just making sure that we connect to the right industry partners that might be potential off-takers in the, let's say, this real world hydrogen infrastructure modeling. This could be refineries and other, let's say, highly energy intensive industries around Europe. So that was essentially it, what I want to present about test line 7 and Youwind. Feel free to ask any questions, and I'm happy to answer any doubts you might have for this.
Thank you. Thank you very much, Edvald. And you see, as a sneak preview, actually Youwind is now in Barcelona. Originally, they were positioned in Iceland, but now they are closer to mainland Europe, I'd say. So this is also a useful point of contact, of course, and maybe the opportunity, we will have the opportunity to visit and to see some of the platform in action. Okay, so we have now finished the session where we presented the 4 test lines, which are up for grab, basically, for access in our first open call. So we do have a question, which is really a generic question for the team. So this is the case of a technology which is a hybrid between 2 different technologies, thermo and electrochemistry, and maybe there are other developers who have a hybrid technology. So the question is, are we out of scope, or can you help us find the right potential testing partner? Maybe Pietro, you would like to reply to this question?
Yes. First of all, thanks for the question. What we believe is that our test line should be as much as possible adaptable, and therefore we have selected a sort of a number of potential technology, but this doesn't mean that we are very focused on those technology. So what we believe is that working together with the user and the innovator will be quite important and a requirement for us in order to adapt the test line. So it will be a work with the single entry point to address the user to the right test line, and then with a strong interaction between the user and the test line to adapt the infrastructure in order to be able to host any technology, even hybrid one, and study the performance and upscale the technology. So I wouldn't say there is out of scope, rather adaptation of the test line and of the infrastructure. And these are feedback that we need in order to scale up our own infrastructure as well.
Thank you. Thank you, Pietro. And of course, you have seen today we have 2 physical test lines, and of course we have 2 digital test lines, so to say. So what is the requirement for accessing these facilities? Do people need to go physically to the facilities, do you think? Especially the physical one, of course.
I believe for the physical one, it's better because I can allow anyway a really good and let's say prolific interaction with the users and with the infrastructure leaders. I believe it's quite important for physical test line to do the test together with the user. Clearly, it doesn't need to be a constant presence of the user, as it could require several hours, even 1,000 hours of tests. So sometimes the presence is not needed and the test can go on. But for, I believe, the first interaction and in order to understand what the infrastructure can do and what are the needs of the user, a physical presence could be worth. And but we are very adaptable, and if it is not possible, we will find other solution.
Thank you, Pietro. And last is more a comment than a question. So our audience appreciates and is very interested in this double line that we have between the real and the digital test line. So let's hope that they can actually exploit this duplicity very well. So that's it for the questions so far. So now you have heard about the facilities on offer. Now Mara TUMIATI from Fondazione Politecnico di Milano will explain actually the mechanism for accessing these facilities through our open calls. Mara, if you're ready, you can share the screen and start your presentation.
Let's see if it works. Sorry.
Okay, it's coming.
It's coming in a while.
Okay.
Let me know if it's working.
If you would like to switch on the presentation mode, so
Yeah.
at the right there, yeah.
You see it now?
Perfect.
Okay, here
Thank you.
Okay, guys. Hello, everybody. My name is Mara, and I will guide you, I promise you, very briefly. It's just about 10 slides to the end of this webinar today. So stay with us for some other minutes to learn more about the open calls. So I will start with the concept of the open calls, because you might not be familiar with this concept that was introduced by the European Commission time ago. And it's getting more and more space in the European projects. So what the concept is a sort of funding scheme that takes place in a funded Horizon Europe project. It means that only funded European projects can introduce this sort of competitive funding scheme to external participants to the consortium. So it means that we have the H2SHIFT consortium made up of several beneficiaries. You see us in this webinar, some of us, not all of us. But we can have the possibility to open the activities to H2SHIFT to external organizations, which will be the applicants, the open calls, because the European Commission thinks that it can be a very useful way to enlarge the impact and to implement the activities of the project, which are the objectives of H2SHIFT. So this is the general concept of the open calls. In general, we can have two types of, let's say, funding schemes. In some projects, the project gives money to the applicants, to the winning applicants of the open calls, to implement some activities. In H2SHIFT, we do not give any money to the applicants, to the winning applicants, but we give for free the access to the test line to validate the technologies. So this is a very fundamental difference between giving money and giving access for free. And I can assure you that in most cases, the value of access for free the facilities at the test lines is much higher than the amount of money that we could give to the companies. So you will not receive any money, you will receive free access to the test line. Moving on to the purpose of the open calls, why the European Commission introduced this concept years ago, because it helps testing, validating innovative solutions, developing new solutions that cannot be tested or developed internally by the partner consortium, but need the support of external partners. For this reason, we try to open up a little bit the consortium and to give you the possibility to external entities to take part to the project activities. And this clearly increased the outreach and the impact of the project, because it clearly helped the demonstration phase, experimentation phase of the technologies that we could not do internally within the consortium. How the H2SHIFT open calls work. So we will have the official opening of the open calls on the 10th of December. So up to now, you cannot submit any application. You can start submit your application from the 10th of December to the 18th of March next year. It will be quite a large period of time. So you will have time enough to work on your proposal, to interact with us, to solve your doubts, and to send the application. Then we will need the evaluation phase. We will take a couple of months between April and May next year. And once we select the beneficiary of the open calls, again, it will be around April and May, once we close the evaluation phase, you will be able to start your activity, which means the testing and validation and the using of the test lines, starting from July 2026 to January 2027. This is very important to note, because you only have this window of 7 months to use, to exploit the test lines. We cannot go beyond January 2027, because as announced already in the previous presentations, we will have a second, let's say, wave of open calls in 2027. So we need to be sure that everything for this first wave of open calls is closed by January 2027. Who can apply to the open calls? Startups and SMEs from all over the world. We do not have any limit in the participation. You can be based in other countries, but Europe, it's not a problem for us, but you need to be a startup or an SME. Large companies and individuals are not allowed. We will do some preliminary check for the eligibility check, and being a startup or an SME is an eligible criteria. Any other kind of institution or subject is not eligible. Moving on to the test lines that are of interest of this open call, you have already gone through a very detailed explanation, so I'm not going to repeat it. You see here the 4 test lines, 5, 6, 7, and 8. The first 2, based in Italy, Politecnico di Torino, are the physical one, let's say, where you could access the venue clearly. And number 7 and number 8 are the digital one. So we are really very happy that you appreciate this mixed approach of test lines. So I'll move on to the next slide because I've just, summarized some details here, but you will have the full explanation of the test lines in the application page of the open calls. So let's see what is the timeline. We go a little bit into details. So you will have the application phase starting from the 10th of December at 2 in the afternoon, and we will close the application phase on the 18th of March, right before midday. You will find all the information and the open calls web page starting from the H2SHIFT homepage. So follow the project, follow us, and you will find directly on the homepage of our website a specific web page for the open call, where you will also find all the documents that are needed to apply correctly to the open calls. You will find the regulation documents, the fact sheets of the test line, everything that can be useful. You can also find the contacts to get in contact with us, clearly, in case of doubts. So everything will be thoroughly explained in the open call web page. Then, as I said before, we have the evaluation phase in April-May 2026. We will do the eligibility check, as I mentioned before. We will go through some evaluation criteria of the application. Clearly, we will have to evaluate your proposal. And then we will form a short list, a preliminary short list of the best applicants. And then we will organize some interview, one-to-one interview, to learn more and more in depth about your proposal, about your application. And then we have the acceleration phase, which will go from July 2026 to January 2027, as I said before. And it is the implementation phase of the selected project. It means when you really will test your technology. Okay, moving on. Let's see some of the evaluation criteria, but again, everything will be thoroughly explained in the regulation document. So I just give you some bites here of how we are going to organize the whole process, but then everything will be clearly explained in the related documents. So the criteria to evaluate your application will be some general criteria, clearly, and some technical and business-oriented aspects. I've just mentioned some of them, but clearly we need to understand whether your solution aligns correctly with H2SHIFT needs. We will also check the innovation level that you are proposing during your implementation project. And we also would like to understand if you have a business model which is solid, scalable, reliable, to understand whether the technology you are proposing is, let's say, solid enough to be market ready, or at least very close to the market exploitation. And then we'll also consider some general features like the team, your experience, and how the team is composed, the skills you can provide. We would like to understand more about your partnership that could strengthen the project, that could make the project work better. We would like to know whether you have some patents or in general, how you're going to handle the intellectual property rights and so on. So our evaluation will be quite wide. So don't get scared, but these criteria allow us to better understand about your project, about what you want to do, and what are the real outcomes that we could expect. So, as I said before, once we shortlist the best applicants, we will then go through the interview phase. I've summarized it a little bit here just to give you an idea on how the process will develop. As I said, we will have one-to-one interviews with the consortium partners, the technical side of the consortium, clearly, to give you the feedback and to comment on your proposal and to check how it fits with the H2SHIFT needs. We will clearly focus on what are the expectations when you validate your technology, what are you expecting to get. We would like to understand with you how this technology will help your company or startup grow in the future. And as I said before, as I mentioned before, we will also consider which kind of let's say business model this technology solution can have. So it will be a very comprehensive one-to-one meeting, interview, but it will be fundamental to, close the circle with the technology to let you access in case you will win the test lines. Then we will have the final selection and we will choose the best application we have received, one per each test line. We cannot support more than one application per test line. I see there are some questions, but I swear I'm at very end of the presentation. This is my last slide, then we can cover the question immediately after this last line. And then we have the acceleration phase. You remember, you have the submission phase, the evaluation phase, and the final one is the acceleration phase, in which you will work strictly in contact with the test line owners. Again, bear in mind that we only have 7 months to test the technology. You don't have to start in July if your need to use a test line is shorter than 7 months, clearly. But you can coordinate directly with the test line owners to exploit the use of the test line as better as you can, or as much as you can, to reach the final outcome. Actually, I've come to the end, so I tried to give you some highlights on how the whole process works. I hope you could follow me, but if there are questions, and I'm sure there are because I saw them, so I would stop my presentation here, and I'm really happy to reply to any doubt you may have.
Thank you. Thank you, Mara. Thank you all. It was very, very clear. I think the question came in about really what about the other test lines? So someone saw the other test lines are actually included in H2SHIFT. So will we be able to access them also?
Well, not this time. So let me make a step back. At the beginning of our presentation of our webinar today, we said that we have 9 test lines. So to be clear, we have organized the project activities into 2 waves, we call them, of test lines. This is the first wave of open calls. It means that you can only apply for one of the 4 test lines that we presented today. Later in 2027, you will be able to apply to all test lines listed in our project. So clearly you will be able to potentially access the test line to validate your technologies, also in other test lines that were not presented today, but later in 2027, not now.
Thank you. Thank you, Mara. That's it for the question. I don't know, Pietro, do you wanted to add something?
I think we went through everything, and I hope the message is clear and loud. We are open to collaborate with innovators. We're open to host tests on our facilities. We strongly believe that this is the right way to accelerate the hydrogen market, to lead to a important technological portfolio for Europe to achieve all the targets and decarbonize our countries. So I really hope was of interest for everybody, and increase the interest to participate to this open call, to stay tuned with our project. Clearly, we have a newsletter, we have a website, and we have a social page where like LinkedIn or X, Blue Sky, where you can get to know all our activities. So I hope every one of you will be able to interact directly with us.
Indeed, indeed. Thank you very much, Pietro. Indeed, stay in touch, because as Mara was saying, we will be soon open the facility for applying to this first wave of open call. So check our website. The start, of course, is the 10th of December, but maybe you will have the opportunity to also download the regulations beforehand. Do subscribe to our newsletter and follow us on LinkedIn, and then we also have X, and Blue Sky. And then we are organizing two stops of our roadshow in the coming months. So you will be able to physically meet with us and speak directly with the test line owners for any doubt you might have. So for this roadshow, we will be in Paris on the 26th of January, just before the start of the High Evolution event. Of course, we will communicate broadly about this opportunity to come and meet us in person. And then we will also be in Turin at the beginning of February. We are deciding the date between the 4th and the 5th of February 2026. In this case, you will also be able to see the two physical test lines that we are opening for access on this open call. So that's it from our side. Please stay in touch, as I said, since I am responsible for communication and dissemination, so you can get in touch with me, but also you will be able to get in touch with the team through the website. So just use also this QR code for accessing the website. This webinar, as you've seen, has been recorded. We will make it available in its entirety or parts of it on our YouTube channel and with links from our website. So we are looking forward to hear from you in these few days. Please do ask questions if you have, and we will do our best to get back to you. So I thank you all for staying with us this morning, and from all of us, see you soon and speak to you soon. Goodbye, everyone.
Thank you,
Goodbye.
everyone. Goodbye.
Thank you. Bye.
You. 5.
Okay, so if the speakers can stay just 1 second. Oh no, they've all gone. Okay. Okay. Ciao, Francesco. Thank you.